Today's lesson is going to be pertaining to the integers and the operations that we do on the integers. The first slide will show you the relationship of the integers to the number line. Many of you may have seen the number line before. It is just a horizontal line that is numbered from 0 to positive numbers going to the right and negative numbers going to the left. 0 is not positive or negative. Any number on opposite sides of 0, those are called opposites. So, for example, -1 and +1, we call opposites. A whole set of integers is actually an infinite set. We denote that by showing that it starts at -infinity with the 3 dots, and then we can give a list of numbers, -5, -4, -3, as you can see, and it keeps going on forever up to positive infinity, again shown on the right by the other 3 dots. Numbers are written in order on the number line as we go from left to right. For any 2 numbers on the number line, we say that the one on the left is less than the one on the right. So the symbol for less than, it looks like an arrow pointed to the left. It always points to the smaller number. So if we turn the symbol around, it will be pointing to the smaller number again, and we would call that greater than. For example, if I have these few sets of numbers and I want to put either a greater than or a less than into the box, if I look at the first example, number 3, -9 and 2, -9 is to the left, so we would say that is less than 2. 7 and -13, 7 is to the right, so 7 would be greater than -13. And then for the 19 and the -19 and the 6, the -19 is to the left of the -6, so that will be another less than. Another thing that you will see in this unit is the absolute value. The absolute value means the distance of the number from 0 on the number line. So basically, all you need to do for an absolute value is to just think of the number's distance, but don't worry about which direction it is from 0. So if it's to the left, the absolute value is 4, and if it's to the right, the absolute value is also 4. The symbol for absolute value is 2 vertical bars that go around the thing you are taking the absolute value of. You would treat it as a grouping symbol, so if there is more than one thing inside, you would do that first before taking the absolute value. It's very easy to take an absolute value, and because all you really do with it is take the positive value of the number. So if the number is negative, you are taking the opposite of the value, and if the number is positive or 0, the absolute value is the same thing. For example, if I have a -3, the absolute value of that would be +3. Again, the distance of -3 from 0 is 3. The absolute value of +25 is also just 25, and the absolute value of 0 is 0. So the easiest way to remember absolute value is just to remove the sign and take the number part of the value, but don't include the sign at all. Another term that you need to be aware of is the opposite. When you talk about the opposite, you're talking about the number that is on the opposite side of 0 on the number line. So the opposite of a positive number is its negative, and the opposite of a negative number is its positive. To show the opposite, you would write it as a -x. So -x, that's read the opposite of x. So for example, if x is -3, -x would be the opposite of -3, which is going to go to the other side of the 0, so it would be a +3. So the opposite of a negative is a positive, and the opposite of a positive is a negative. Now we will get into the 4 operations. If you need to start learning the 4 operations, especially the addition on the number line, sometimes that's easy to understand. So for example, if I have 2 plus a -5, I would start at the number 2, which is on the right of the 0, and then if I add a -5 to it, -5 goes to the left. So if you start at 2 and move 5 units to the left, you will be at a -3. All right, we will be learning rules that you can use in a couple of slides where you don't actually have to use the number line. But here's another example. If I start at -1 and add to that -3, I go from -1, 3 units to the left, and I'm going to end up at -4. So if I add 2 negative integers, I would just keep adding the number part of them, which is their absolute value, and I would keep the sign negative. So 2 negative numbers, and when I add them, will also be negative. Here's some examples. So if I have a -5 and a -7, I add the 5 and the 7, which makes 12, and keep the sign negative. If I have negative 8 and negative 2, I add the 8 and the 2, which is 10, keep the sign negative. One thing that's important is if you have a 0, 0 added to anything stays a 0, or stays the number. Okay, the 0 is called the additive identity, and 0 will not change the value of the sum. So for example, negative 4 plus 0 is negative 4. So here are the rules for adding positives and negatives. If you have two numbers that are opposite in sign, you have to subtract the smaller from the larger and then take the sign of the larger. So if the negative one is got the larger absolute value, you will have a negative answer. And if the positive one has a greater absolute value, you will have a positive answer. So here's an example of that. If I have positive 11 plus a negative 8, you subtract the 11 minus the 8, that gives you a 3, but the larger one is positive, so that will give you an 11 minus the 8, and that will give you a positive 3. The second one, negative 7 and 4, if you subtract the 4 from the 7, that will give you a 3. The larger number is the negative, so you will keep the sign as negative. Notice it doesn't have to be the first number in the problem. Those two examples just happen to have the larger number as the first number, but whichever one is larger, that will be the sign of the answer. If you have a lot of numbers to add, you can add them in any order you want, but usually it's better to do them from left to right. So here's an example where I would add the 15 and the negative 2. That's going to give you a 13. Then that 13 plus the 7 will give you a 20. And then that 20 plus the 14 will give you a 34. The 34 and the negative 5 will give you a 29. And finally, the 29 and the negative 12 will give you a positive 17. So again, remember, when you are adding two positives or two negatives, you add the numbers and keep the sign. But if you're adding a positive and a negative, you subtract the smaller from the larger and then keep the sign of the larger. Okay, on to subtraction. Now in subtraction, we are actually going to do the opposite of addition. So what we will do in subtraction is we will change the subtraction sign to its opposite and also change the next sign. So if you look at the problem that I have here, negative 12 minus 30, you would take the subtraction sign in the middle and make that a plus, and then take the sign on the 30. Now 30 did not have a sign on it, so it was assumed to be positive, so you would make it a negative. So you change the subtraction sign to addition, and then you change the next sign to its opposite. So I will end up adding a negative 12 plus a negative 30. Okay, and again, if for that problem, if you're adding two negatives, you add the numbers and then keep the sign, so that answer will be a negative 42. All right, here's another example. I have, again, a negative 20 minus a negative 17. So again, I will change the subtraction sign to addition and then change the sign on the negative 17 to its opposite, making it a positive. So in this problem, I would end up adding negative 20 plus 17. For this problem, then, you are adding two numbers with opposite signs. So the answer to this will be a negative 3, because you will subtract the smaller from the larger and then keep the sign of the larger, which is negative. So again, here's a couple more examples. 10 minus 7, that is the same as taking 10 plus a negative 7. So again, you change the subtraction to addition, and then the 7 becomes a negative 7. Again, because these two are opposite in signs, we subtract the smaller from the larger. So 7 from 10 is 3. The larger sign was positive, so the answer to that is a positive 3. For the last example on this page, again, change the subtraction to addition, and then the negative 9 becomes positive. So again, we're going to be adding a negative 4 plus 9. So again, in this case, we are subtracting the smaller from the larger. So 4 from 9 is 5, and in this case, the larger was a positive. Okay, one last example on subtraction. Same thing, the negative sign will become, on the subtraction will become an addition, and then negative 3 will become its opposite. So you'll have a negative 7 plus 3. Again, subtracting with opposite signs, you subtract the smaller from the larger. So 3 from 7 is 4, and keeping the sign as negative. If I have a large problem like this, where I have a string of subtractions and additions, the first thing that I would do is I would change all my subtractions to addition. So the first sign in between The -3 and the -5 is a subtraction. So that one will become plus a positive 5. Then in front of the 9, it's a negative, so that will become plus a -9. And then on the last number, the -6, there's a subtraction in front of that, so that will become plus a 6. In that case, you will now have all additions to do, and you can add those numbers any way you want to. If you would like to add them from left to right, you can. This example actually added all the positives together and all the negatives, and that's another way that you can do your problems. Okay, now on to multiplication. In multiplication, the rule changes when you're multiplying two numbers that have opposite signs. The product is going to be negative. So all we do is to see if the sign is the same or opposite. So if the signs are opposite, the product will be negative. If the signs are the same, the product will be positive. So in this case, I have three problems. All the signs are opposite. There's one positive and one negative. So if you notice, every one of those products will have a negative answer. The other case is if they're two of the same sign, so two negatives or two positives will give you a positive answer. So again, in this case, I had two negatives in each of the problems, so they both gave me positive answers. So again, the rules for multiplying: you multiply the number part, the absolute value part. If the signs are the same, the answer is positive. If the signs are different, the answer is going to be negative. One other thing you have to be careful on is powers. Again, when you have an exponent, we talked about these in the last week. When you have an exponent, it just means you're going to multiply your base that many times. So in the first problem here, I will be multiplying the -7 two factors. So again, two negative signs is going to make a positive. But in the next problem, I'm multiplying 3 factors of -4, so that will end up to be a negative. The next example is a little tricky. When you have a negative sign in front of the base, but it's not inside of parentheses, you are not squaring the entire -7. When you have something like -7 squared, it really means -1 times 7 squared. So remember, you're supposed to first do your exponents before your multiplication, so this answer will come out to be a -49. So again, be careful when there is a negative sign in front of an exponent without a parenthesis. It does mean that the answer will be negative. The last operation is division. Okay, so in division, we use the same rule as we did for multiplication. If the signs are the same, the quotient will be positive, and if the signs are different, the quotient will be negative. So in the first example here, I have opposite signs, so the quotient is a negative. In the second example, they're the same sign, they're both negative, so that answer is positive. And then the last sign, again, opposite signs, so the quotient is negative. A couple of things that you have to be aware of: if you have a 0 in the numerator of a fraction, the answer is 0. Okay, that any number in the denominator is fine. You'll always get a 0. This just means I have 0 things divided into a certain number of groups. But the other case does not work. If you have the 0 in the denominator, we would call the answer undefined. Okay, so I think there might be one of those in some of the quizzes or the practices this week. And again, if you have 0 in the denominator, you say the answer is undefined. So again, multiplying rules are the same for dividing. So multiplying and dividing have the same two rules, which are to multiply or divide the numbers, and then the sign of the answer will be determined whether the two signs are the same or whether the two signs are different. Okay, if they're the same, the answer is positive, and if they're different, the answer is going to be negative. Again, division by 0 is not defined. We call this an undefined answer. 0 in the numerator is fine as long as the denominator is not also 0. So again, a couple examples. If I divide 0 by -6, I get a 0. If I divide 0 by 12, I get a 0. But -3 divided by 0, we call that undefined. Now back to the order of operations. That was also in week 1's information, but we're going to add in our negative numbers. We do exactly the same thing we did last time, which is all the grouping symbols first, then the exponents, then multiplications and divisions left to right, and additions and subtractions left to right. So there's no change in this at all, just the fact that we may have negative numbers or absolute values in here. So first example, I have one with absolute values. The absolute values act like a grouping symbol. So you do the inside of the absolute value first. So the first thing I would do inside that absolute value is the cube. And cubing -8 means cubing -2 means -2 times -2 times -2. And that will give you a -8. Continuing in that absolute value sign, you divide -8 by 4. Again, two signs opposite in division will give you a negative answer. All right, I'm ready at that point to evaluate the absolute value. So the absolute value of -2 is 2. Then I can go on with the question. I still have the subtraction and the multiplication. The multiplication would go next. So I would leave the 2 and leave the subtraction and multiply 5 by -2, and that's going to give you a -10. And then the last operation there is the subtraction. So again, remember, subtracting is the same as adding the opposite. So that will be 2 plus 10, and that's going to give you an answer of 12. All right, the last thing is that if you ever have a fraction bar, that actually is going to be a grouping symbol. So if you have a fraction bar, you do the entire numerator, you do the entire denominator, and then the last step is the division. So here's an example. We would do that entire numerator first, and if there had been anything else to do in the denominator, we would have also done that. So in the numerator, you're first going to do the square of the -3. So -3 times -3 is 9. You end up with 5 minus 9, and again, that's really like 5 plus a -9, which gives you a -4. So you do the entire numerator first. If there had been anything to do in the denominator, I would have done that next, and then finally I would do my division. This concludes our little lesson on our orders of operations on positives and negatives, and also working with our different operations on sign numbers.